For this project, we were asked to design a mathematical model to describe the motion of a water spout that was coming out from a hole made in a plastic tube. Mathematical models are tools that help us understand the world in a better way. They try to be as accurate as possible, but they may or may not have a certain range of error. The first part of the project, we designed a plastic tube, which had a hole at the bottom.
So after designing the plastic tube, which was 1 meter tall with a diameter of 6 inches, we put the fluxometer in the floor, we added some water, and immediately observed a relationship between distance and time as the water was going out.
We were asked to determine the distance of the water spout against time.
And in this case, the distance is a function of time.
Next, we designed a mathematical model taking into account formulas given to us by our teacher. The first formula we used for this project was velocity equals the square root of 2 times gravity times the height of the water. Second, we used a formula that goes as derivative of volume over the derivative of time equals the area of the hole times velocity. The next thing we did was create a formula to obtain a new volume. This formula equals the volume, which equals the area of our tube times the height of the water minus the area of the hole times velocity times time. Then, to obtain height as a function of time, we used our new volume, this formula we got, over the area of the tube, of the base of the tube.
We then described velocity as a function of time. We took the formula and wrote height as a function of time, and this is equal to the square root to 2 times and times area of the base of the tube, then times the height of the water, minus 10 times area of hole times the square root of gravity, and all of these over the area of the base of the cylinder. So we got the model, and with this model we can find time and volume, and we plot a graph of distance versus time with the results of the experiment. And we got a function, and with this function we plot another graph, that this one shown here.
Next, considering this is half parabolic flow, we tried to describe the time needed for the spout of water to reach the ground. What we did here was take the formula distance equals the initial velocity on y times time plus 1/2 of the acceleration times the square of the time. Then we isolated t, time, and we got our time.
In the second part of the project, we were asked to calculate final velocities of 4 shots of the slingshot. We had to download the application of an accelerometer and throw our phones with this application in order to find the final velocity. The formulas used in this part of the project were given by the professor in the class, and these ones are the following.
As part of this project, we made 4 shots of the slingshot. All of these slingshots have the characteristic of having a stretch of the sling of 15.24 centimeters and a mass of 0,1322 kilograms, which is the mass of this iPhone. The results obtained from this project were recorded in the following Excel tables. With the acceleration obtained by the app, we found out the final velocity of the iPhone. Concluding, we can see that often accelerometers can be useful to help us better describe the way an object behaves. while in movement. As a recommendation for following projects, we strongly recommend to find quality materials because we have a rough time using our slingshot. As another recommendation, we recommend buying a professional accelerometer in order to get better results.
So in the next videos are presented the four slingshots at different angles and different forces, and these are the variables. And